Hello boys and girls, welcome. In this video we're going to talk about work. You were supposed to do some research before coming into this video, so I recommend that you guys have your notes and your book ready just in case you need a refresher for this topic. Let's begin then. So, what is work? Okay, if you guys think that work is going to a place and performing menial tasks with a specific amount of skills that you guys have simply to get paid to survive or to be able to survive for one more single day of your existence, then you're right. No, but in all seriousness, the scientific definition of work is the act of exerting force on an object and causing that object to move in the same direction of the force. So think of this man over here, for example. He is pushing his car. He is using force to push the car in this direction. If the car happens to move in the same direction because of the force exerted by this man, then it is said that he is doing work. He is moving the car in the same direction as his force. Okay, so this takes us then to basically two rules that need to be fulfilled in order for work to happen. The first rule is no movement, no work. What happens if this man is pushing against the car but the car doesn't move? Then he might be exerting force, but there is no work being done because the car is not moving. Now, rule number two. Imagine that, let's say that this man over here, maybe the car, turned off, I don't know, for whatever reason, in the middle of a hill. And this man is trying to push his car up that hill to get it over the hill. But the car is actually moving backwards. It's sliding backwards, right? So he is exerting force, but because the car is moving in the opposite direction of his force, then there's no work. The movement in the opposite direction of the force, that means no work. Let's look at three separate examples then of what is work. Look at this girl over here, for example. She's picking up this backpack upwards. That means that she's doing force in this direction. But then she starts walking in this direction. What's happening in here? Well, you see, she is exerting force in this direction upon the school bag, but she is moving in this direction. So in this circumstance, there is no work being done. What about this one? Okay, so the girl has to bend down and pull on the backpack in this direction. The same direction as she is walking then, all right? Or maybe her arm is moving in this direction as well. Because the force she's applying is in this direction, and because the backpack is also moving in this direction, then you have work. Work is happening in that situation. Now look at this example over here. This is a very particular example. What's happening in here? So instead of picking up the backpack, she's actually grabbing it from the handle. She is also picking up the backpack in this direction. She's applying force in this direction to pick it up. And she is moving in this direction. The backpack is also moving in that direction. But because she is doing two movements at the same time, one going up and one going to the east, then we result with a movement that goes in a diagonal direction. Okay? The force being applied takes a diagonal direction. So what does that mean if the girl is moving over here to the right, to the east? It means that there is a specific amount of work being done, but not the optimal one. Why? Because the girl is moving in this direction, but the backpack itself is moving in a diagonal direction. Okay? So, work is being done, but it's not the optimal work upon the school bag. So, calculating work. The amount of work done on an object can be determined by multiplying the force times the distance the object traveled. The unit of work is the joule, which is basically newtons, which is the unit of force, and meters, which is the unit of distance. So the formula is going to look like this basically. Okay, your equation is going to look like this. Work equals force times distance. Again, the units should be newtons times meters. But to make things more simpler, we're going to use the joule then. Alright? Keep this equation in mind as we're going to be using it later on in later videos. So then, what is power? Nope, it's not that.
By the power of Grayskull.
No, it's not that either. Power is the amount of work done in a specific amount of time. So, this is the equation for power, basically. Alright? We got power, which is work divided by time. Because work is equal to force times distance, and you can say that F, force, times distance, divided by time, is also power. Okay, so you got two formulas for power. All right, I'll have to admit there are more complicated formulas for work and for power, but for now we're gonna stick with this ones basically. All right, so keep this in mind: power equals work divided by time, or it's the same as saying force times distance divided by time. The unit of power is the watt. If we take the unit of work, which is the joule, and the unit of time, which is the second, you're going to end up with joules divided by seconds. But it is much simpler to say watt. All right? Let's take this example then. All right? Let's use this example to visualize the idea of power better. We have two cars in here which are about to go in a race. The distance that they have to travel, the amount of meters they got to travel, the distance is 25 meters, starting from here all the way to the finish line. All right. So let's pretend then that these two cars have the same weight. All right, have the same length, the same amount of tires. Everything about them is identical except for their motors. Okay, for their engines. The engine of this car over here, let's say, does more work than the engine of this one. So what's going to happen? Well, of course, if this car is exerting more work than this car, it's going to take a lot less time for it to travel this distance, okay? We can find the power of this car, the red car, simply by dividing the amount of work that this engine is able to produce divided by the time that it took the car to travel these 25 meters, okay? Another way of saying this is that we can measure basically the force that this car exerts times the distance, okay? And then we divide it by the time that it took the car to travel this distance, and we get the power. Okay, don't worry too much about it. So right now, we're gonna in later videos we're gonna actually talk about practical cases. We're gonna calculate power and work. Okay, but right now, without any quantifiable measurements, we know that because this car over here has or produces more work and took less time to travel the distance, then we know that this car has or produces more power than this yellow car over here. I hope this was helpful for you guys. I hope you guys learned something new, or maybe clear up some things that weren't clear for you. Okay, so if you have any more problems or any more questions, you know where to find me. See you around.